He viajado al otro lado del mundo, en Milán, Italia, pero puedo decir que es muy bonita aquí, en Colombia. Es mi segunda vez en Colombia. He visitado Monteserrati por las 2 veces. It's so nice to be here. I did speak Spanish many years ago. I can probably understand you if you come talk to me in Spanish. I'd love to hear from you. I don't speak as well as I used to, especially about technology and about all the things I've been doing. I haven't done any of that in Spanish, but I can maybe talk about the weather or your food or the job you're doing. But I am so grateful to be here. I'm always impressed by the people I meet when I come here. Everybody here is so eager to learn, so kind, so engaged. It's just phenomenal, actually, what we're doing here. So I wanted to see if I could talk. I'm not sure if this will work. Actually, maybe you have to have some software installed, so I may just have to come back here and tip the button when I need to change things. I have a ton of slides, so most likely I won't go through them all. Hopefully I'll kind of rapidly go through what you want to learn about, and if there's questions, I can talk about things in more detail. But I have definitely been doing Python for a long time. And I started doing Python much like people here are doing Python, just because I was curious, just because I wanted to solve a problem I also had. And then what I encountered is just amazing people all over the world, who then together we could start working together to do things. And I would say it's probably just stubbornness, persistence, maybe ADD perhaps, I don't know, just keep working on things that are working. You push against the world, and some things don't move, but some things do. So I've had a career actually working on a lot of different projects. So up here, I'm going to go through a little bit of this. I won't cover everything that I've had a chance to be involved with. I know where a lot of bodies are buried, basically, kind of why things are the way they are, because I've been using Python since the very, very beginning, not as early as Guido, but in 1997, I started to use Python and started to contribute to Python in basically 98, 99, and really outside. I was a scientist, so I love math, I love physics, I love science, and I was an applied scientist. I was not a computer programmer. However, I learned programming as a young person. More science led to Python. So I was trying to solve big equations and solve big data processing. I was using MATLAB, needed more memory. I encountered Python. And it was curiosity that led me to actually contribute. I needed to read data. That's all I needed to do. I needed to read data into a format, DICOM format, and I didn't know how. I was using the numeric library. It was previously written by Jim Huguenin. There was this great guy, Michael Miller, who made an example, and he actually published his example on a blog, and he published the code, and I could see it. It wasn't quite as nice as GitHub today. You actually had to go click a button and download and untar, and then look at it in your Emacs editor, which I'm sure most of you have used here, right? We would open the code, and we'd look at it, but he basically had an extension module. So Python, how many have written an extension for Python? My guess is not too many these days, but yeah, look, very good. Yes, I mean, one thing, if you haven't explored the Python code base, do yourself a favor and look at it, right? Do yourself a favor and explore, and you don't have to be an expert. The C code, the C languages, you may not know C very well, but you can learn a little bit, and you can certainly see the C code, and it can make sense. So that's all I did. I looked at his code, and oh, that's how you extend Python. I can get that. So I did what most people do. I cut and pasted the code, and I started to make some changes, right? And then that was what got me on my journey, and I was able to fairly quickly create another extension module that did it the way I wanted to do. So he wrote data into a table. I wanted to read data into an array, and so I basically wrote NumPy.io and put it out in June 1998. And I put it out meant it wasn't as easy as today. I put it out on a website. There was no GitHub, there was no place to put it. I had to take patches. People would send me difference files, the diff command, and I'd use the patch command to make it. But Guido also published a lot of information. He wrote, and Guido's a great writer, he's a great community leader, and he basically wrote this essay on how to do reference counting. Now, many of you probably don't know about reference counting. Fortunately, you don't have to worry about it, but if you're writing an extension of Python, you do. You have to keep track of who owns the objects and when are they going to be released. Python is memory managed, it's just not automatically memory managed. You basically have to tell it when you're done with the object and increase the reference and decrease the reference. The reference counting is actually one of the reasons the GIL's hard to remove, because you basically have all these little reference counting hacks you'd have to put. But anyway, knowing that led me on this journey. So first of all, great people who are sharing their code and sharing their ideas. it sort of got, we need to do that. We should do more of that. I should share ideas. We should promote what we're doing and share other people and then let them do what they will with it. I'm absolutely sure Michael Miller had no idea that his contribution would lead me to write a bunch of code. I basically delayed my PhD work. I was married, had 3 kids at the time, and so my wife probably wasn't that happy that I was not getting a job and making more money. Instead, I was writing code for free and giving it away. But I just could not help myself. It was just so awesome to take something I could do, which is learn about optimization algorithms, numerical algorithms in Fortran, make an extension module to Python, then make it accessible to anybody in Python land. And I started to do that in 1998. So that was the first project. It's grown, of course. Like anything successful that happens, you see this. It always starts with a few people, but it's really crossing that barrier to getting more people engaged as to what makes it really work. And today, SciPy works because it's got 1,000 contributors. Now, it's a power law. There's probably 13 that really contribute a lot. But everybody's contribution is super benefited. And I've met some amazing people, actually. P.R. Peterson, one of those folks who helped me very early. He now works with me. I'm so grateful he does. And I saw him just last week in Milan. SciPy ultimately is what led me on a journey that led to Anaconda, because SciPy was really a distribution of Python masquerading as a single library. The reason we put all this stuff into one place is because it was so hard to install anything. So when I first shipped SciPy, I shipped it, as all good developers do, as a single big tarball of source code. Right? That's how you all get your software, right? You go download a tarball, unpack it, do the build command, build it yourself, right? Like, that's how we do. No, I'm sure you don't, actually. What I noticed is I had about 10 users after about 6 months of shipping that way. There's a high school student named Robert Kern who basically wrote a Windows installer for SciPy. And he did that, and he was an amazing kid, actually, super smart guy. He's still in the SciPy community. But he wrote that Windows installer, and I noticed suddenly the number of users went up dramatically. People could just click and install SciPy as an extension module or as an EXE. That process is what really led me to ultimately spend time on packaging, on shipping, on how do people get the software installed. And I'm still having conversations about that even today. And that's a longer conversation I won't go into here. But that's why. Like, how did a guy who does science and loves to measure satellite information and process images and do MRI and ultrasound end up starting a packaging company? Right? How does that work? Well, a little bit of the story you can see now. I was a professor for a while because my love was science, and I fell in love with entrepreneurship and business because of my passion with open source. So for me, it went science led to open source. Open source led to how do I pay for my kids, because I already have them and I can't put them back, and I love them. But they take money, and believe me, they take more money the older they get. They were actually cheap, younger, and now they're all older and they're still taking a lot of money. How do I make money if I'm giving software away? So that led me to study economics and learn a lot about, try to learn more about economics. And I'm not saying I know everything about economics, but I learned a lot. And one of the things I learned was how important entrepreneurship is, how important it is for humans to have businesses that interact with each other, and how important the market is to sell to each other. Really powerful ideas that I was just not aware of before. So I learned those ideas and realized I want to be an entrepreneur. I want to create aligned businesses. And then essentially, the experience with open source, experience with entrepreneurship led me to what I'm doing today, which is essentially trying to help create open source aligned businesses. That's what I basically do, a bunch. But my open source addiction, which it really kind of was, I love just participating in open source, and many of you can relate, I think, because you realize just how much you get from you give, and it's just amazing, and I love it. The problem was NumPy. There needed to be a thing called NumPy, and NumPy came about, and it's actually the thing that's most popular. Most people don't know NumPy came after SciPy. I wrote NumPy to save SciPy, basically, because SciPy was starting to get replaced by other libraries on top of NumArray, which is another library. So those who don't know, we'll talk a little about NumPy later, because I'm going to talk about array-oriented programming, because my passion is array-oriented programming, helping people do tensor programming. Some of you here know what I mean, some of you may not. But the NumPy array is the foundational kernel object that gets you doing array programming. If you're only got about 1,000 elements you're worried about, you don't really need array programming, except that maybe the idea and the thinking is nice, but it's not faster. Python's fast enough for thousands of objects. You start to get beyond that, tens of thousands, millions of objects, you should definitely not just be using Python lists and objects. You should be condensing those into arrays. And there's a whole system here. Now, I didn't create the first version. It was there when I came. I came to Python because Jim Jim Huguenin and Fulton Pryor had built kind of this SIG, this special interest group, doing arrays. And numeric existed. Also, Harry Greenfield, who I know from the Hubble Space Telescope, I knew him because of the SciPy connection, he was starting to write NumArray. And that was happening, and I did not want that merger, that change to kind of split the community. So that's really what led me to basically out of duty, out of a feeling of, well, nobody else is going to do it. I don't know if I can. And it really stretched me basically because I was a scientist who was basically now all of a sudden building a type system. And frankly, I built a Python 1 version of the type system. If I'd have known better today, I would have at least built a Python 2 version of the type system because I was kind of understanding that. But anyway, that's a longer conversation we can go into if anybody's interested. I can go into some depth about what I learned about what I should have done. But anyway, NumPy did succeed, it emerged, and now it's got millions of users and millions of dependencies, which just baffles my mind. It blows me away how impactful it's been. I did not predict it. I knew it was important, I knew I should do it. I felt really, I was actually working as a professor, and my boss, my department chair, had just told me a couple years earlier to spend more time on writing papers and doing research and not so much with the open source community. I know you like it, but write papers and grants. But okay, I'll write NumPy, which, and you can imagine the tenure review process didn't go that well. It was basically a bit of people kind of came back and said, well, they didn't say no, but they said come back later. Well, that led me out of academia. I said, I'm not going to do that. So I left academia and went into a company. The whole time I wrote NumPy, I wanted a compiler, and I wanted a compiler for a very specific reason. Anybody who knows NumPy here, raise your hand if you know what a ufunc is. A ufunc, universal function. Oh, I'm so sad. Okay, do yourself a favor and go learn what a universal function is. What a universal function is it's basically a multiple dispatch typing system inside of Python. And it's sitting there, and it's been there for 30 years, basically, ever since numeric in 94. And what it does, it enables you to do sine and cosine and add and subtract on arrays of numbers. Big arrays. So you just have to say one add. You don't have to have for loop, don't have to say for I in and do that double thing. You just say add, and all the arrays add. And I like it. It's a beautiful framework. It's a really cool framework. But the challenge was, how do I write a new one? How do I make a new function that does something new? Well, you had to write C code. You had to write an extension, a NumPy extension, basically, to make a C code. And I did that in SciPy.special. Go open the SciPy.special library, and you'll see a bunch of them that I added. So I was probably the world's expert on ufuncs, actually, at one point. Probably still am from the audience to this audience, apparently. It needs to get more known, but the reason I wrote Numba, I wrote the first version of Numba. Fortunately, other smarter people came and wrote better versions of it, but the idea was there. The reason was to make ufuncs. I wanted to be able to make a new ufunc without writing C code. So I wanted a specialized compiler that lets you write Python syntax and then produce a fast function. And it's really cool, actually. And now Numba is just one of many. JAX, Triton, PyTorch, TensorFlow, like everybody's doing it now. Specialized Python compilers for the data science and array community. And it's very different. When I wrote Numba, it was the same time. There was Unladen Swallow, there was PyPy, and we tried to have conversations, but they really didn't understand me, honestly. I was like, I think I understand where you're coming from, but I'm not trying to write a general purpose replacement for Python. I actually like the Python runtime, I don't mind it. I just want to speed it up sometimes. I want to write extensions really fast and connect with the Python community better. So that's where Numba came from. It's used now, and it has 13 releases, 301 contributors, and really the first of many that exist now. So these side projects that I did, and I was a scientist doing research. Eventually, I started as a scientist, this crazy point-haired scientist. I became a programmer, not as handsome as this guy. My family, I have a big family. I have 6 kids, beautiful, lovely wife, lovely kids. They're mostly out of the house now, but I have 2 more in high school, one just graduating this year. And so all along the time, I've been having kids and having this family to support. So that kind of led me to say, well, I got to figure out how to support them. I better learn more business. And so I've been learning kind of how to become, and now basically I'm a pointy-haired boss. Is basically all I do. It's pretty sad. But I do like coding. I did a little bit of coding that I'm going to show you a little bit later. I mostly find people. I find tech visionaries, founders. I feel like I want to connect people who need to build with capital and money that can build it. So I'm really excited. Deb gave a great overview of the PSF. I love the PSF. It's a wonderful organization. I created a similar organization for the NumPy SciPy ecosystem called NumFOCUS. intended to be array-oriented, kind of inspired by the PSF that I knew about. And so I have a lot of different things I'm involved with. I left Anaconda, so some of you know me because of Anaconda. I started a company called Anaconda, and I'd love to talk about that in detail, but I'm not there anymore full-time. I left and started Quansight, which is the foundations. And Quansight does consulting using open source, but it does something that I really love, which is it has an open source research lab called Quantite Labs. And there's some people here in Colombia that actually work with me there, and it hires people to work on open source. In particular, NumPy, SciPy, Pandas, and so I'm grateful to say that we have scikit-learn, Pandas, NumPy, and SciPy developers that we pay full-time, and they get to spend at least half their time on these projects. So it's an organization that does this. It's a global organization. People all around the world join. And then we have this other place. We fund it from consulting, but we also fund it by making investments in innovation. Companies, things like Anaconda, things like other companies, and as those companies do well, we do something that I think every single VC on the planet should do. We're trying to be an example. You know, not many people are looking at me yet. Maybe I'm not rich enough yet. I probably never will be, honestly. I give money away. But I love every single VC. If you talk to your next VC company, say, yeah, how much of your carry are you giving to open source? Just ask them that question. They'd love it, yeah. How much of the carried interest you're earning on the investments you're making are you giving to the open source communities that are at the foundation of what you're building? Because everyone should do it. It's actually a built-in, it's a no-brainer. Everybody should do it. And so we're doing that. It's a long-term funding strategy. That's what we do. That's why we created it. So I find people, some of you might know Tanya and Rolf, they run labs. They're pretty semi-independent, really grateful for them. They do a great job. And then Darhas and Lalita just joined us as kind of on the management of the consulting side. Super excited. Some of you may have seen the Quantite Lab's annual report. Go look at it if you haven't. We're having some real impact. We love to collaborate and cooperate. We actually fund NumFOCUS. We have a pattern we've established. We call it support. There's a lot of companies out there that hire people to work on open source, which is great. We love it when they do that. You know, NVIDIA hires 10 people to work on NumPy. That's super cool. Okay, who's going to keep supporting the NumPy infrastructure? NumFOCUS. So we have a policy that if we hire people and work on NumPy, a percentage of what we pay them, we send to NumFOCUS. We just built that in as a policy. It actually works pretty well. And so now NumFOCUS is a built-in sponsor. If everybody did that, we'd actually have a lot of money coming to the PSF. If the PSF did this, like, hey, Microsoft, you just hired a bunch of people to work on Python, Instagram, anybody working on Python, hey, support the community with a percentage of their salary. Actually, it's a good idea. I'd recommend it. Maybe, Deb, we could talk about how to encourage your companies to do that. Yeah. So what I've done is try to figure out how do I scale Quansight? Quansight's awesome. I love it. How do I get 10,000 other companies just like it to organize? And can I help them? Can I help you? Can I help anybody who wants to build a consultancy or open source research lab do that? So we basically factored that out into OpenTeams. OpenTeams is sales, marketing, HR, and recruiting, and support. And we support Quansight, but we can also support anybody who wants to build a consultancy that's open source aligned, an open source aligned consultancy. So that's what we do. I won't go into much detail. We do have something called OSSPM I'll talk about later. One of my favorite things we're doing, what I'll be doing until hopefully 90, if I can live that long, at least in my 70s, is OpenTeams Incubator. I love helping entrepreneurs create companies. And I'll be doing that. I get excited about that all the time. I made a ton of mistakes with Anaconda. I made a ton of mistakes with Quansight, make a ton of mistakes with other companies that I've been involved with. I want to help people not make some of those same mistakes. Can we help them? So we have an incubator that does this. We raise money from partners and invest in again, open source aligned businesses. They don't have to be technology companies. They can be companies that are changing the world in other ways, but need technology. In fact, I think there's enormous opportunity there. Many of us think we got to go work for a technology company. Don't think that. You actually need to use technology to work to make the world better, which means there's tons of companies out there that need software and they need software to be better, but that software should be based on open source. And so when you're making that software better, also make the communities that you depend on better. And there's straightforward, simple ways to do that. Love to help brainstorm with you about how, but that's what we do all the time. I won't go into detail here. I will say anybody here, we are doing something pretty new in OpenTeams called the Osa Community. Osa means open source architect or open source aligned, depending on the mood I am in. But they're both, it's basically finding people that want to build better software for companies on open source. Come be part of a community, a conversation. We attach to conferences, we have a Slack channel, easy to join. You do have to have it be experienced. It's not a place to just be new. You basically have to have about 7 years of experience in software and about 2 years at least of leadership experience being a technical lead. If that fits you, come join the community and participate in the conversation. And some of those people may become a partner and then benefit more economically, but you don't have to. One of the things I'm very excited about, it's coming soon, so it's kind of vaporware right now, but it's not that we've done it already with DataDash APIs. If you haven't seen DataDash APIs is my answer to the problem of, okay, NumPy merged numeric and numarray, cool, you made a single array object. Fast forward 10 years, 12 years, and there's like 10 arrays. There's PyTorch, there's TensorFlow, there's a lot of them actually. I did a survey. Do we make another array object? Well, instead we basically did an API. We said, let's make a standardized API that multiple arrays can support so that people building on arrays can just use the API and they know they're going to have a standard. So we're doing that not just for arrays, but also data frames, which the arrays has gone super well. The data frames is still a work in progress because data frames are newer and there's many more people out there doing them. But it's making great progress, actually. I'm really pleased with this. It's coming out of labs. Rolf Gomers is leading the effort with a few other people. But it's prompted this idea, because what we did with data APIs is we got collective funding. Basically, it's something we call a community work order, which is a statement of work, but where it's driven by the community needs. It's not the company doesn't go, okay, I want this and this, I'm gonna order myself some open source, right? That doesn't work very well. I'm gonna order up some features. It's not really how it works. Companies can express interest in feature areas, and then the community can discuss how they want to implement those feature areas. And that's what we call a community work order. You're funding community to solve problems that they'll do, they're willing to do, they want to do, that are related to what you care about. So it's a matching bit. And you can also, as a company, you could say, hey, I've got 50,000, I've got 10,000 to spend on this. Maybe there's others who can help, and together we can come up with 100,000 or 200,000 to fund this effort. And that's what we did with data APIs. And so with repos, we're generalizing that. So look for this in a couple months, and if you're a maintainer of a project that wants to get funding, talk and make your proposal and we'll help find matching funding for you. Or if you're a company wishing open source would do some things you care about, you can flip the other side, put some things out there and we'll help you match with maintainers willing to help. So that's reimbursement and enhancement proposals for open source repos. If you're not experienced yet, you don't have the 7 years of experience, the 2 years of leadership experience, but you want to get involved with open source and figure out what a career in open source looks like, OSSPM is for you. It's the Open Source Professional Network. Think of it like, they give Academy Awards, there's an Academy for filmmakers. Like, where's the global group that is supporting people who want to make careers out of open source? That's what OSSPM.org is here to do. It's a free, you just join, you get a profile, a place to promote your who you are, a place to kind of connect. It's still pretty early, but this is something we're going to be supporting and maintaining for a long time. It's like NumFOCUS, it's like PSF, it's an effort, it's not a company, it's a movement, it's an organization. OSSPM.org, and go ahead and join. You're free, anybody can join. Still incubating this big idea. I think I've figured out a way to actually have open source market. They have every company that's benefiting from open source have some of their proceeds and some of their equity, their value, flow back to the community. If we could close that loop in a very real way, we'd actually solve the sustainability problem. We'd have other problems. There's a lot to do there. It's a lot of work. I don't have enough budget right now to pursue this completely, but we've done some preliminary gardening, preliminary digging in the space. If you're interested in this, and I put this slide only because there might be 1 or 2 people in this audience who really cares about sustainable open source, who wants to say, how do we actually make this work for the long haul? This is the first idea I've had that I said, this could work. This is essentially $1 trillion idea, but I'm actually not, I'll say it to this community. I don't like to say that to VCs because then they they'll break it. Basically, it's not to control anything, it's actually to help sponsor something and grow something. I think it's definitely a possibility. So we've had some ideas still working. The next segment of my talk, I want to talk about, so this is what I'm doing in, kind of, what am I up to? And I care about open source. I'm really the same person that was a young man experimenting with Python. It's just, I'm now experimenting with refactoring organizations and people and trying to help make connections between business ideas and creating aligned businesses. I still like coding. I still have a lot of ideas or thoughts about lots of, particularly packaging, particularly compiled Python runtime. At one point I was a core Python maintainer. I had a chance to get a few peps pushed through the process, but this is like 15 years ago or 11 years ago, a little bit different now. But one of the things that I've been passionate about the whole time is this concept of array-oriented computing. So what is it? What do I mean by it? What I mean is organize your data together logically, instead of being scattered everywhere, organize together logically in arrays and tables, pull it all together. And then operate on chunks at a time. So think operation on the array at a time, not just individual rows, not individual objects. If you think that way, you end up programming that way, and then you can actually do more with less. You can make it faster, you can take advantage of modern hardware, and it's becoming even more important. I spent some time writing a compiler to make it easy not to have to write array-oriented code, but ultimately, modern hardware, if you want to write code that can run on GPUs, run on CPUs, run on multi-core, and you look at the machine learning, look at transformers, look at generative AI, all that effort, they're using array-oriented programming. Like I would say, generative AI is succeeded because of high-level array-oriented programming. So write code at that high level. Array expressions, vectorized broadcasting, instead of for loops. That's what I mean by array-oriented computing. So, little visual, here's memory using object-oriented programming. Each object has its attribute. All the poor people that had to learn Java, they thought about, this is what they think. They think all these objects float around in space. I've had a lot of code bases I've seen where this is the way that people thought. And I have to figure out how to undo that because it leads to bad performance, bad memory management, bad design, effectively. So, one simple thing to do is just organize all your stuff together. Your objects are rows, your columns are attributes. And now you can actually think about things like, I could take a computation around an attribute at a time without having to do this, find the object, load it, find an attribute, load it. I can actually just do an index and go get a lot of computation done quickly. So this is one approach. You get a lot of benefits by thinking that can code this way. Unfortunately, there isn't much education about this. You can find a few people online who talk about it, but not very many. There aren't that many. If you ask ChatGPT, for example, it'll definitely confidently say a lot of stuff, and you might feel like it knows what it's talking about, but every time I've asked ChatGPT to solve a problem, it kind of does things, but it's always using for loops, it does use NumPy, which is like, okay, apparently there's enough NumPy usage out there that it interpolates between those users. It's okay, but a lot of algorithms can be expressed at a very high level, and then when you write it that way, parallelism happens automatically. Right? Parallelism is hard, right at a high level, it comes for free. That's kind of one of the benefits. If you know PyTorch, some of you may know, probably all of you are aware of generative AI and LLMs. Fewer of you know about PyTorch and how it works. It's actually super complicated, unfortunately. I wish the world, honestly, with the right funding models, we could have a world where it was actually closer to kind of the community-driven ecosystem that could have led to this. Actually, it was on its way, but we just didn't have GPU support for NumPy. We just didn't have automatic differentiation in NumPy. And we didn't have a mechanism to get funding from companies to go to open source very effectively. NumPy array looks like this. I'm not going to go too much into detail here, but effectively, the Python object just talks about, it gives you information about this big chunk of memory. Right? Normally, a list will have a pointer to every object, and every object will have Python header information, and then the data itself is a tiny piece of information. So NumPy collects it all together, and then it has shape information. And then NumPy does a thing that is kind of what I should have done better. But there's something called an array scaler. There's a Python object for every kind of type that can be in a NumPy array. So when you select out an element of a NumPy array, the thing you get back is another kind of type, is another Python type. That's called an array scaler. So there's kind of a Python type system a Python 2 type system sitting in NumPy, but it's kind of double duty. NumPy examples, so you create a large array, then you can do things like sum across an axis, you can do calculate mean, standard deviations on 2-dimensional, 3 dimensions, slicing's a big deal. The extended slice syntax, you notice how there's just a comma, 4 colon, comma, 4 colon, and also the extended slicing notation, 2 colon, colon 2, right? The fact you can do that is because Guido made concessions to the early array community. Like very early on, this is before I joined, Guido had allowed there to be, okay, we'll have extended slice syntax. He's scratching his head going, I don't know why we ever use that, but sure, go ahead. And so we did, it was awesome. I wish we would have got metric multiplying at that time. That took a lot longer as the community got bigger, but finally it got in too. The comma, the fact that tuples in Python come from just comma, right? That's here. Part of that reason is because of this. Because without it, you'd have this extra parentheses. You'd have a bracket parentheses, something comma, then a parentheses. It just looked bad. And so, but Guido made it general. He said, oh yeah, sure, we can get rid of it. Let's have commas imply tuples. And that's really cool, really helpful. I want to go an example of array-oriented computing. Just give you an example of what it looks like. I'm going to skip the APL thing. That's what that cryptic spelling right there is actually a single line program for the game of life. One line, right? But APL got a little overzealous about their use of cryptic hieroglyphs, right? I mean, it's helpful to kind of have common syntax or common at least letters. We know what we're talking about. I don't know if anybody knows what bezier curves are. Some of you might, if you're in graphics, right? Bezier curves give you a simple way to parameterize a 2 or 3 or dimensional curve. It gives you a parameterized curve. It's very straightforward. If a little complicated, those b sub n sub I as a function of u use the parameterization, usually goes from 0 to 1, and then it gives you an x position and a y position. And here I'm plotting y versus x. So u is kind of implicit. It goes to, from the beginning of the curve to the end of the curve, and those control points are plotted. The control points are not on the curve. The control points are just guiding the curve and telling it where it should be. But it gives you a very straightforward way to model any curve. So my son was working on Bezier curves with my brother, who's an engineering, mechanical engineer, and he was looking for Bezier curves to model pumps. And so my son was looking at it. So, of course, he went to ChatGPT and said, okay, cool, get me a Bezier curve implementation with ChatGPT. I just did this today, actually, again. I said, okay, give me a Bezier curve implementation. And it did. It kind of, even use NumPy, right? It gives you, lin space. I'm in the way here for some of you can't see this. Lin space, control points, math factorial. Actually, ChatGPT gave me np.math.factorial, which is cute. I mean, yes, it's true. The NumPy does embed the math command. I said, let's not pretend that math is part of NumPy. Factorial, then the binomial coefficient calculation at the end. It does this curve I plus equals blending function. I mean, it named the cell. You can roughly see that it does what you want it to do in fairly straightforward terms. Great, awesome, and that actually works. This works pretty well, works decently. Somebody who uses NumPy would come to this and go, wait, why do we have these for loops here? I count 2 for loops there. What? There should be, 0. The fewer for loops, the better, basically. I want just code without for loops. So let me think about this. I need to broadcast. I basically need to take, I start with a 2D array. I start with a 1D array of samples. I need to broadcast that to a 3D array. That's what that slice selection looks like. I put none, comma, none. That just makes a 1D array into a 3D array with 1 element in each of the other dimensions. So I have a 3D array for the parameter. I'm using t instead of u here. Control points, and I have the control points. There's a 2D array initially, n plus 1 in this case, comma 2. I want to make it a 3D array. I'm going to add another dimension to those control points, okay? Now I have this index across the control points, j. I could just make an A range of those, but I need a 3D array. So I'm going to put new dimensions on the outside of that. So you can basically see here, each of these things, t is the first dimension, control points are the last 2 dimensions, and then j is the second dimension. But they're 3D arrays, all of them. Now those can be added together. I can just make a single, binomial calculation. I can just do a single calculation, no for loops, no looping over data. I just do all the calculations at once and all the values at once. And now the curve is just summing over that axis, that j-axis. And that's the code. My son couldn't write that code. ChatGPT didn't give me that code, but it's pretty straightforward to write that code once you understand what you're doing with array-oriented computing. And that code can be parallelized pretty easily, actually. That code work on GPUs. That can be compiled to run on a GPU pretty quickly. So it's a lot better to write this code than to write the code 3 times, once for a CPU, once for GPU, and so forth. So it's never been more important. And it turns out, in this particular case, I just ran this earlier today, 32 times faster to write it just like that. And so, it's a little learning. It's not obvious necessarily. That's what it should look like. But that's what I'm here to encourage you to learn and to think about and to say, if I want to step up my coding to a higher level, my data processing coding, learn array-oriented computing. Zen of NumPy, just put it here because I put it together a long time ago, inspired by Tim Peters, import this. Strived better than scattered, array-oriented better than object-oriented, and think in higher dimensions is basically the final end. So the last part, I want to talk about a couple just ideas and how you can get involved. So I only have a couple of minutes if I want to leave time for questions. Array-oriented computing is actually succeeding. It's actually pretty cool. They don't call it that. They call it tensor computing. I'll give in. It's fine. I mean the same thing. It's a tensor, for those who are mathematicians, actually technically means something different. Fine. They'll have to come up with a different word. NumPy's been growing steadily, but you see immediately once TensorFlow started showing up that an increase occurred. Now TensorFlow is being surpassed by PyTorch. There's a good reason for that. TensorFlow is not community-oriented. TensorFlow is ivory tower, here's my code, dump it on you and hope you can succeed. PyTorch, also big business funding it, but they are, Sumit Shintala is really working to try to get it community-oriented. That's why it was donated to the Linux Foundation. That's why he wanted to make sure it was put to the Linux Foundation. He wants PyTorch to be more about kind of coming from a community space. There's a lot more to talk about there, and a lot more of what does it mean and how do you actually do community-driven at scale and how do you get funding to coalesce to support this amazing effort that happens. The scientific Python community has been growing for a long time. It's been a subpart of the Python ecosystem. Like I was here for a SciPy conference initially, and there's a Pycon conference. There's SciPy, PyData, Pycon, and the people that come to those aren't all the same people. How many people here have gone to a SciPy conference? Yeah, see, the same people that knew what UFunks were, so it makes sense. Yeah, totally cool. And again, not everybody needs to go. It's actually fine. You don't need, go to the conferences that make sense to you. But there does need to be collaboration at the high level. There does need to be collaboration. I would say an ask, Deborah, for the PSF. My ask is how do we make the scientific community connect with the PSF in a stronger way? So there's more representation on the steering committee, there's more representation for the language, there's more representation for this whole ecosystem that lives outside of some of the orbits of the people that are just focused on Python only. Because this community has been living for a long time, kind of in the Python community. SciPy was initially as a library, but it's also a conference and a community, basically. Those are now sort of separate things. But the SciPy conference started 21 years ago as a workshop in Caltech. PyData as a conference started 10 years ago, really more focused on like pandas and Jupyter notebooks and so forth, and then the business use application, business analyst application of Python, and that's been growing. But the movement started even earlier than that. SciPy was a thing we created after coming to the Python community, which already existed. There was a matrix SIG in 1995. I didn't realize how new it was, but it was pretty new. And Jim Huguenin, and this is the first thread on the mailing list. That's what we did back in the day. We had mailing lists, and I don't know if these archives are still there. I know we go to Discord, and it's actually harder now. You got 15 places to go talk to people. And back in the day, we had one. We had a mailing list. It was pretty cool. I'd love to see a little more kind of help, like where do we talk? How do we communicate with everybody? But I call it the SciPy data community now. I co-opt that term. 28 years. So it's a big community, a lot of people doing a lot of things, a lot of scientists, a lot of researchers. I would say people that don't think of themselves as programmers. Talking to IBM, talking to Microsoft over the years, I've had lots of conversations where they basically said, oh yeah, we think there are 12 million developers in the world. That was at a time, I was at Anaconda, when Anaconda had 20 million users, right? Like known IP address users, not just downloads, but like users. And I scratched my head going, how do you think there's only 12? Like, you must think what a developer is something different than I think of a developer. And I think that's it. Like, there are a lot of people who use Python who don't think of themselves as developers. They have something else they're doing, something else they care about, something else they're trying to do every day. They just use programming too. That's a big community of people. And they've been there for a long time, and there's a big group. Lots of stuff still needs to be done. So a lot of stuff has been done in this community-driven, very community-centric, people-centric way. But there's so much still to be done. I've heard people tell me things like, oh, it's all been done before. There's not enough to do. There's not anything to be done. And I kind of scratch my head going, there's actually a lot to do. Yeah, so if you're looking for ideas, let's have a chat. Let's talk. Here's just a simple set of stuff that I think needs to be done. A lot of stuff around better funded open source communities, more savvy open source aligned businesses. Obviously, this is something I care about. How do we get business to be more open source aligned? We need better software that lets experts in something besides programming use the computational resources without sacrificing too much performance. Python's been operating on the boundary of that space for a while, and it's done a pretty good job, actually. There's more to do. It's done a pretty good job. Dashboards and visualizations that connect real time to data. Data integration, data management's a big problem, but you see all the time people kind of writing reports or writing, here's my report, it runs a week. Well, can I just click this button and have it updated like now? Oh, well, no, we've got to go through 15 iterations to get you another report. And then, of course, sharing and reproducing is a big problem. This community, I will say, it's my one ask, right? Please, please, please don't encourage people to ship vendored wheels. Right? Don't encourage people. I know pip is nice. I know you love it. I know that this whole pip Conda thing. We created Conda to solve SciPy data problems. Right now, there's a lot of other things that have emerged. There's other good solutions emerging, but pip is not solving the problem yet, and it's actually creating more problems by encouraging people to vendor wheels. What that means is, oh, I have TensorFlow, the Python library. It also depends on TensorFlow, the C++ library, and 3 other C++ libraries that are not Python at all. How do I get the person to get those installed? Oh, I know, I'll just package them into the wheel. And so all of a sudden you're pip installing something that's a Python library that embeds a particular branch of a Git repository that has other releases that you've just vendored. You can make it work, it works, but the technical debt is real, and factoring that out is hard, and you're basically making the problem harder. You're making a problem even harder. There are better solutions out there, they just need improvements to the pip ecosystem to take advantage of them. Another thing I think is underappreciated is Cython. Cython is a fantastic extension module creator. It's underfunded. There's only a few people maintaining it. Anybody here use Cython? Raise your hand if you're a Cython user. Okay, a few more people like that. Cython's a brilliant library. It actually was primarily funded and grown by Sage Math. William Stein, a good friend who did this incredible work to create Sage, which is a mathematical application using Python. And he used Cython to create a lot of extensions. It basically would have made my life a lot easier if I could have just written Cython code instead of all this handwritten extension code that uses figuring out memory tracing and reference counting. But Cython is a compiler in a world where all the compiler people are going to other places they think is more sexy. So Cython's underfunded, needs a lot of help. There's a proliferation of tensors and data frames. Everybody's in the game now. Everybody's doing their own thing. Cooperation, standardization. Data APIs is actually an effort in that direction. It's going pretty well. PyTorch and TensorFlow are very complicated. Would love to see something there in the future. There's too much reliance on C++, I think. I mean, Rust is cool. C++ used as more like C is fine, but the object model of C++ is actually pretty complicated. And you can write it, but then maintaining it and getting other people to use it, and you've really focused. It's hard to do community driven with that kind of difficult to. You can write amazing C++ code that nobody can read. That they can read you, they can use the library, but kind of figure out what the meta template programming is doing. It's kind of like debugging is twice as hard as coding. So if you write code the very best you possibly can, you'll never debug it. Like a lot of C++ looks like that. It's like, that was super clever. I have no idea what it's doing. Good luck maintaining and explaining to somebody else. Funding and support for open source governance, community support, difficult. I want to see a much more diverse funding fabric. Like that, if I could say one mission I have is to make lots of companies. I'd love to see people here, owners of companies, love to see people kind of able to participate in the funding fabric and not just be behind a few gatekeepers. Like we need to just open up participation. So there's a lot of opportunity. That's just, there's a better list out there you can make. I'm gonna go quickly through this. I'm actually not gonna skip, I'm gonna skip all this actually and go just to the end. We've done some cool things in Nabari and data science and, this one. I really promote these two ideas, community-driven open source versus company-backed open source. Both are great, both have pros and cons, but just know what you're getting into. If you're joining a project, understand, is this company-backed, meaning the governance of that project requires you to work with a company, versus community-driven, which is the governance of that project is just managed by a state. You could become the governor of that project if you have enough time and effort and connection. Both have places, but both have different implications for you as an individual. So pay attention, but they're community-driven. You have to pay attention, is this project maintained? Does anybody care? Is this two people and nobody else? These are important things to think about. Say no to vendor wheels, already said that. Conda does have best practices. I won't go into that. We're doing some work on that. I'll just close by some final suggestions on how to get involved and how to do more. First, get interests outside of coding, right? You're all here because you like coding, cool. You all have some probably pretty cool interests too outside of coding. That's really important. I would say my life as a programmer was much enriched by my interest in science and math. And this is my journey. Like I love math, physics, electromagnetic waves, medical imaging. That led to Python, led to open source, led to economics, that I'm interested in, entrepreneurship, data science, now AI, I'm interested in AI, I'm interested in human organizations, like not just artificial intelligence, but actual intelligence. What does it mean? What are humans like? How do we work together? How do we align together? How do we work together at scale? And there's some interesting things there. Man, it's never been a better time to be a Python programmer than today. There are so many cool libraries out there. I mean, this isn't even doing justice, right? There is so much out there today. Like I went, okay, now I know there's more Python compilers. I did some research on Python compilers. I found 6 I didn't even know about. Like, oh my goodness, there's so many smart people doing amazing things. And the cool thing is, these open source projects, most of them you can get involved. You just go email the person. Hey, I like what you're doing. I noticed there's a documentation issue. Maybe I could help. Here's a pull request. Just get involved. Triton is one some of you haven't heard of. Triton lets you write Python code that creates faster PTX code for the GPU than CUDA does. So OpenAI created Triton, and it's the spirit of Numba. I love it because exactly what it's trying to do with Numba. We saw, hey, if we write code at a high level, we can build better binaries. We can build faster code. They're doing it, and they're doing it amazingly, actually. And now PyTorch depends on Triton because they did such a great job. And they're doing better than the CUDA programming. So it's really super awesome. And awesome Python has more lists there too. Dive deep into things. You've got to know about stuff. There's never been more opportunity if you dive deep into something. You can't just watch quick 30-second videos and you won't learn enough. Like you'll know enough to talk and have cocktails with somebody, maybe drink a cerveza, but you won't be able to help. It does take concentrated effort to learn deep, and there's tons to learn about, from WebAssembly, which PyScript is based on. If you want to help Fabio with PyScript, go learn WebAssembly. Then you'd be awesome. Go learn the details of Web3. Linkers and loaders, how do systems actually work? How do they go from code to something that shows up in my OS? And what does that mean in a world? The LLVM infrastructure is just really cool. If you learn LLVM, you can just do magic in Python. You can code generate. And then posits. Posits are I'm a curious person. There's actually a new way to represent numbers on computers. Super cool. As you participate in open source, do so authentically. What does that mean? I don't know. But some smart people in 2020 kind of got together and made a list that looks pretty good. Because you see a lot of people doing open source now, and you kind of go, what makes open source so it becomes like the Python community, and what makes open source so it becomes like, I don't know, the TensorFlow community, right? Well, yeah, it's open source, but everybody's just mercenary there. They're just getting a paycheck. So how do you make it so that it's not? And there's some people thinking about that. How does it work? I think starting early is one. I can certainly vouch for that. Sometimes you're embarrassed because you put out a project before it's perfect. And I know a lot of people have this sense of, I got to do all the hard work, then I'll dump it onto the world, and then it'll all be great, right? That's not how NumPy worked. That's certainly not how SciPy worked. And yeah, it's embarrassing because, there was some stuff there that's kind of crummy. But the cool thing is, you actually got people to go, hey, I can make this better. Like if you did all the hard work, then there's nothing to do. And then people go, okay, thanks. But there's nothing like getting people who actually mix their effort and time into your thing. So then that's their thing now too, and now it is truly a joint community thing. I think starting early is important. Putting community first, and this is really important for me as I think about businesses. Seen it numerous times. I love businesses. The community about open source projects are different. We have community-driven innovation. That's why Quantite Lab is a separate organization. We have people putting community first is really critical. Understanding what the community needs are. Listening, a lot of listening. I was having a conversation earlier today, and one of my colleagues listens super well. Fabio, you do an amazing job. You're a great listener. And then be clear about your motivations, like why are you doing this? Enforcing respectful behavior, then having an exit gratefully. I have exited from my efforts, like both at NumPy, SciPy. You don't do it forever, and other people need to take over. Finally, code with a community. And that means care about people more than code. Ultimately, it's us together that makes Python amazing. It's us together that make the world amazing. It's us together that will make the next generation of software amazing. So let's keep going. Thank you.